Hello everyone. I'll show you two approaches for making Pixelart analog clocks in Godot. One uses multiple line 2D, the other uses a shader. First, on the basic setup. Create a new node 2D, add your clock sprite, make sure that the sprite does not contain any arms, then add a timer node. Finally, add a new script to the node 2D. There, reference the timer node and add a new function that loops every few moments. It will first call our function that sets the clockwork, then starts the timer and waits until it expires. At the end it will call itself again, completing the loop. If your clock does not use seconds but only minutes and hours, you can set the timer interval to 60 seconds. To finish the initial setup, I call this function onReady, which will start the loop. Next, I'll go over the line2D approach. This is useful if the stretch mode is set to viewport and the camera is not zoomed in and you won't adjust the scale of this clock. If any of these conditions are not met, you can skip to the shader approach at this time step. First, add a line2D node. Add 2 points in the line. Make sure the first one is in the center of your clock. The second one can be wherever you want, but make sure it exists. Then adjust the width and color to your liking. Next, add a new empty script. Name the class and add a variable for the length of the arm. Also add a function for setting the arm's position. This will use an angle and radians to set the arm's position. We'll use the arm's length for a new vector and rotate it correctly. Then add the center position to make it revolve around the clock center. Finally, set the second point's position to our new coordinates. Now, let's go back to the script from our initial setup. Add an export variable for our second line. Add a new function to set the time on the lines. There, first get the current time and then call our previous defined setArm position function. As an angle, we will use the seconds as a starting point. To go from a range between 0 to 60 to a range in radians, I first multiply by 6 to get to 360 degrees. Then divide by 180 degrees and multiply by pi to reach radians. If you shorten it, it comes down to this. Lastly, call this function our previously defined loop function. When playing the project, it should now look like this. To accommodate for minutes and hours, we can simply duplicate our seconds arm twice. Reparent those to a new node for clearer structure. Adjust their width and length. You can use the second point to play around and see how it would look. Then reference them in our initial script and add them to our setTime function. To go from 24 hours to 360 degrees, I divide by 12, then I multiply by 360 and convert to radians. Shorten, it looks like this. Despite the hours going between 0 and 24, we only use 0 to 12, since that's how clocks work. If your camera is zoomed in or you change the scale of your clock, you will notice that the pixel size will not be correct. If your stretch mode is not set to viewport, it will show us clean lines, which is probably not the desired effect. For both of those situations, I found a different solution using a shader. First, create a color rect. Move it and resize it to fit your clock. Add a new material and a new shader. To make the shader pixel perfect, first we need to tell the shader how big the color rect is. I'll also add a center point, which the arms revolve around. Next, add the arm color and a slider for the seconds. Lastly, we need to set up the arm to length and width. I then convert the degree from a floating range between 0 and 1 to integer values between 0 and our size without any decimal places. This ensures a clean and pixelated look. Like previously, we next get the degree at which to tilt the clock's arm. This time we need to rotate it by 15 seconds, otherwise we would start at 15 seconds and not 0 seconds. Don't ask me why that happens. Next, I want to define a new function that returns true if you should draw a pixel and false if you shouldn't. To set up this function, I first define several variables which will keep it flexible and enables the use of multiple clock arms. My approach to make this work for our clock is simple. Take our pixel coordinates and get its distance from the center. If the distance is longer than our arm length, then we immediately discard it. Next, we calculate our directional vector our arm should go in. Then we multiply that vector by a distance from the center to get the point where we should be on the clock. If the absolute distance from that point to our UV point is lower than our width, we should draw the pixel. If not, our pixel gets discarded. Finally, copy and paste the function to fill in all the variables. This should look like this. You can play around with it by adjusting the second variable on the right. To hook it up with our initial script, we need to reference our color rect, and then add a new function for setting the shader time. Like our previous solution, we use the time dictionary and use those values. By calling the material of our color rect and setting its shader parameters directly, we can change the time. Careful, if you misspell the variable, it will not work and won't give you an error. It should look like this now. Like previously, we can simply add minutes and hours by first setting up the variables in our shader, and then adding more if statements for the other pixels. Finally, we need to connect the minutes and hours in our initial script. Simply duplicate the seconds lines but use minutes and hours instead. Lastly, if you want to make the hour or minute arm smoother, you can adjust the way we use in the time by also using the next lower unit and divide it to match the unit. In the line approach it could look like this. In the shader version it can look like this. Thanks for watching.